Welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my YouTube channel for everything I want to talk about science and math. And today we're doing physical science, and this, you need to hear this too. I didn't have a specific playlist for you guys, so I made a new playlist yesterday. All of your classes are going to be under the elements and mechanics of physical science. So that's where this is going to go. So if you ever want to go back and watch a class, it's a good way of study. Because when I make the test, I hold the notes in one hand and type with the other. So the notes are your primary study guide. Sometimes I'll give you another study guide too. But always learn your notes, because I promise I take questions straight off of them. All right, so what we're going to talk about is nuclear changes. So this is nuclear chemistry. It's the chemistry behind bombs. It's the chemistry behind nuclear power plants. It's behind the sun giving you cancer if you don't put on your sunscreen. Things like that all has to do with nuclear chemistry. What part of the atom do you think nuclear chemistry has to do with? The clouds or the nucleus? The nucleus. You hear it, don't you? Nuclear chemistry. After this, really, we don't talk about the nucleus much again. The nucleus, we're not making bombs. We're not running power plants. We're not treating cancer. So we don't do a lot with the nucleus in science class. What we deal with is the electrons. And what we're going to talk about next is how these electrons can undergo chemical reactions. Does that make sense? Guadalupe, put up your phone. Put up your phone. That's the put up your phone dance. I was trying to give Guadalupe a dance, and she usually ignores me. All right, so these are nuclear changes, and it's a little mini unit. There's not a whole lot of labs we get to do with this unit, because we can't deal with radiation, can we? I'd be blowing you up or giving you cancer, both of which are highly frowned upon by the school board. So can't do much labs with this. We have to do more simulations. When I was in college, we actually did a lab with radiation, and I was a teacher of the lab. If you were a chem major, you got to help teach labs as your student job. So I was a lab teacher, and there was a student who their radiation came in these little pots that sort of looked like the lid to my water bottle, but a little bit smaller. Okay, and I would take a syringe and put something in them, shoot them in them, and then it would start giving off radiation, and the students did their lab with the radiation samples. Well, at the end, I did things like clean up and stuff like that too, and so I was collecting all of the samples of radiation, and I held out my hand for a student to hand it to me, and instead of handing it to me like a not idiot, he turned it over and dumped it all over my hand. So I had radiation all over this arm, and I felt it just pour down, and I was so upset because I'm like, oh no, I'm going to get cancer in this arm now. But it felt really weird. It felt hot, but not just hot on your skin like you're used to feeling. I could feel it hot all the way through my whole hand. It felt hot on my bone. It felt hot on the inside. It was really weird. And sadly, I did not get superpowers. Lab accident, radiation, no superpowers. I'm still waiting for this arm to do something amazing. Hopefully not get cancer. But anyway, the guy, the professor was so mad at him about it, he gave him a 0, which would make him fail the class. So he failed chemistry lab because of dumping radiation on me. So I don't know, it was so weird. Why would you do that? Why would you ever hand by anybody a cup of anything like that? It was so weird. So anyway, we're talking about nuclear changes. So the first thing is these atoms that are, remember how we said isotopes are fat and thin? We learned that last time. The ones that are too fat can give off radiation. So that whatever was in that little cup, and I don't remember, it was too long ago. I know it's hard for y'all to believe college was a long time ago. But whatever it was, it had isotopes in it that probably had too many neutrons, and it was giving off radiation. Radiation is what felt hot to my hand. So what happens is these nucleus start falling apart, and that is called radioactive decay. Radio, just like the one you play in your car. Radioactive decay. Decay is another word for things falling apart, isn't it? When you're dead and in the grave, your body will start falling apart. If you want to see how that looks, watch Walking Dead. They got lots of people walking around in different stages of decay. But instead the atom falls apart. It says this disintegration of an unstable atomic nucleus. That's just a fancy science way of saying it's too fat. The nucleus is too fat, and it falls apart into one or more different nucleotide. Nucleide, not nucleotide, that's something else. That's in biology. Nucleide. So what it is here you've got your nucleus that's too fat, and it will give off radiation. There's one called, are we going to talk more about these down there? I'm showing it here. One type of radiation it gives off, it looks like a little fish. This little fish is the Greek letter alpha, so one of the things it can give off is alpha particles, and that's what got poured all over my arm, was alpha particles. It was that kind of decay. There's another one where it can give off a neutron. The symbol for a neutron is a lowercase n. You learned that in the last test, remember? I told you the symbol for a proton is lowercase p, the symbol for neutron is lowercase n, and the symbol for electron is lowercase e. A neutron has no protons, so this little symbol right there is 0, but it has a mass of 1, so that's the symbol for a neutron. It can just throw one of those out, it's so fat. There's another one called gamma. It looks like little ram's horns. If you have ever looked at horoscopes, the symbol for Aries is that. It looks like just little horns. So that's another kind. So when it does this, when it falls apart and it has radioactive decay, it gives off nuclear radiation. Nuclear radiation. Nuclear radiation. That's the particles that are given off from a nucleus. That's where they come from. Comes from the nucleus during radioactive decay. Radioactive decay. Okay, so radioactive decay is given off by an unstable nucleus because it's too fat. It gives off radiation, like alpha. There's beta, gamma particles, neutrons. They're given from the nucleus. This is the nucleus of the atom, and it is called radioactive decay. How do we feel about those words? Can we keep those straight? We've heard of radiation before, haven't we? We know about Bruce Banner. We know about the Hulk. We know about how he got gamma rayed and became the Hulk. See, that was the problem. I had alpha rays instead of gamma rays. I don't think I would want to be the Hulk. If I got superpowers, She-Hulk is very ugly and kind of dumb. She-Hulk, have you ever seen She-Hulk in the comics? There's a girl Hulk. It's called She-Hulk.
What does she look like?
She looks like Hulk, but a girl. And she's kind of ugly.
That would be ugly.
It's ugly. All right, so we're going to talk about different kinds of radiation. And the first one is called alpha particle. And that's the one I got dumped on me, alpha particle. Now, there are different symbols. One thing that makes this confusing is there's not just one symbol for each kind of radiation. Each kind of radiation has several symbols that all mean the same thing. So I already told you the little fish stands for alpha particle, but also an alpha particles are made out of helium. So sometimes they will write the alpha particle as the helium atom. Remember when we did the computer simulation, the PhET simulation, and we learned that the atomic number goes here on the bottom, the atomic mass goes on top, then the symbol. Well, a helium is the same thing as an alpha particle. It's a radioactive helium. Another way they can write it is instead of writing the HE, they'll put the little fish there instead. So they'll do the 4, 2, and the fish, or sometimes they'll just put the fish. All of those three things can mean alpha particle, one type of decay. So alpha particles, what we need to remember about them is that it's a helium atom. It's a little messy. a helium atom, what, no, there's no way for y'all to know that. It's positively charged. It has a positive charge to it. It's big compared to some of the other kinds of radiation. It's tiny, itty bitty. But compared to the other types of radiation, it's the big one, okay? It is easy to stop. A piece of paper can stop it. So that makes me think when I got it dumped on me that there was more in there than just alpha particles, because it felt hot all the way to my bone. And I think my skin should have been able to stop it if it was just alpha particles. It ionizes, which means when you are hit with it, it can turn some of your atoms into ions, which makes it more likely for you to get cancer. Things that give you free radicals is another way of talking about ions, are more likely to give you cancer. And what happens when you have an alpha particle, it will change the atomic mass. Change. Now, in science, you might have suspected we're nerds. And as nerds, we like abbreviations. So there is an abbreviation for change I want you to know. Does anybody already know the abbreviation for change? No? Nobody like chemistry? It's a triangle. You never have to write change again in science or math. A triangle means change. It's the Greek letter delta. So you've learned 2 Greek letters today. You learned alpha, the fish, and delta, the triangle. And alpha is a kind of radiation, and delta means change. In math, they'll also use it as difference. Change or difference. All right, that was kind of fun. You feeling smart, learning Greek letters? Yes, Peyton?
And this one, what's the very last one? That's the atomic mass.
Change. It changes the atomic mass. That when you have alpha decay, the atomic mass of the original atom will change. It changes, I guess I should say. Better grammar. You don't say change atomic mass, you say changes atomic mass. Okay, so that is our alpha particle. Let's see if I can scroll.
That's what we were
Will
saying.
you move it up so we can get to
Yes.
gamma and beta?
So push on that.
You should click, yep, click and roll. Right there.
Okay.
All right, good. All right, so alpha, we got our Greek letters here, our Greek guy there. So we're learning Greek letters, so we got the little Caesars man. He's Greek, right? Okay, so,
He is?
he's supposed to be Greek. He's a toga. He's got the wreath on his head. I think he's a Greek. All right, so the next one we're going to talk about is the one that turns Hulk into Hulk. What is it? Do y'all remember? I just said it. Starts with a G. Gamma. That's right, gamma radiation. So the next kind of radiation is gamma. And this is its symbol, the ram horn, or sometimes it'll just have the horns without the zeros. Those, it looks like a Y where you bend the Y down. Yes, sir? G-A-M-M-A, gamma. Gamma. So here's another Greek letter. We've learned a third Greek letter now. Gamma rays are a form of energy, electromagnetic energy. It's a type of light. It's not visible light. It's high energy light. Very high radiation. It's packets of, okay, the symbol, did I write this on here? I did later. The symbol for energy is capital E. Capital E. Got to learn your shorthands. Ryan, are you taking a picture of the board? And put your phone away. All right. So what it is it's packets of energy and called photons. Do you remember learning this before? That light energy is called photons. Photons. Light energy is photons. Okay? And this is high energy. High energy. And it's hard to stop it. It takes 7 centimeters of lead, so about that thick of lead will stop it. Also, I think 5 feet of concrete will stop it. We'll talk about that in a second. it changes the energy. So we're using our new abbreviation changes here, and we use the E for energy here. We're using some of these abbreviations. That's an
What's
E.
it say for packets of?
Photons,
Packets of.
packets of energy. Big E means energy. Called photons. It's high energy. It's hard to stop. This stuff will really mess you up. If you get exposed to gamma rays, usually you don't turn into Hulk. I know it's shocking. Usually you're cooked like a hot dog in the microwave oven. You're going to be cooked from the inside out and die.
Oh,
Yeah, so you don't want to be exposed to gamma rays.
that's cute.
Very bad. Okay, our third kind of radiation is called beta particles. Beta particles. It's an electron. So the symbol for it is lowercase e. Electrons have a charge of -1 and they have no mass. So that's one symbol for it. Another one, though, it's this. It'll have the 0 and the -1, and it's like a capital B with a tail that's not quite closed up. That's the symbol for beta, and sometimes it'll just be the B without the numbers on it. Okay. So this is called, this is actually an electron, like how that one was helium. This one is an electron. This one's light, that's a helium, this one's an electron. What charge will it have?
Negative.
Negative, yes, y'all are brilliant. Okay, it's very small. It can be stopped by 3 millimeters or a piece of aluminum foil. Aluminum foil would stop it. So that will stop a beta particle. It ionizes, which means it can give you cancer. It changes the atomic number. It changes the atomic number. Okay, how do we feel about all that? There's more on this page though, so don't change yet. Yes, Jada? I'll be showing it off. Ta-da. We'll go over here.
What does the second from the last one say?
The second from the last one is it can be stopped by 3 millimeters of aluminum or a piece of aluminum foil. A piece of aluminum foil could stop it. Y'all are doing great. This is kind of weird stuff talking about radiation. Y'all seem to be understanding pretty good. Good job, guys. All right, there's another kind. We're going to write it in the middle. And I forgot to give you any blanks for it. It's called a neutron emission.
Neutron emission?
Emission. Like how you got to get your emissions so that you can get your tag every year. You know how you have to do the emission test? It's that word. It's neutrons being given off. Neutron emission. The symbol is the symbol of a neutron. It doesn't really change anything except the mass. No change as far as except the mass. And it's stopped by a bunch of lead. Stopped by 15 centimeters of lead. So, oops, I left off my C. Centimeters. So it's about that much lead. About that much lead will stop it.
What'd you say under no change?
It's stopped by 15 centimeters of lead. 15 centimeters will stop it. Okay, we're still not through with this page. We got a couple of other things right over here in the corner. There's a plus sign. It says plus other things. Mine got cut off. Other things, like there's something called positrons. Positrons, and they are like a positive electron. There is something called positrons that are like positive electrons. Now, you will learn more about this if you take physics. They learn more. This is one area where chemistry and physics overlaps, and physics goes into a little more detail. We just sort of scratched the surface. Ashton, put your phone away. Okay, this is the last little bit on this page, right down here on the corner. Let's see if I can scroll that up more. I don't think I can. It's just not on here. Well, maybe it is on here. See my finger? Yeah, that right there. We got it. All right. So this is the last little bit of information I need you to know. What is that the symbol for? 1, 0, little n. What is that?
Neutron.
Neutron. A neutron is made out of, and this is like a secret, a proton and an electron. If you take a neutron and hit it real hard, it'll split into a proton and an electron. Also, if you cram together real hard a proton and an electron, you can get a neutron. So now you see why neutrons are neutral, because they're made out of a positive and a negative. You can see why neutrons have the mass of a proton, because it's made out of a proton. Or you're like going, oh, mind blown now. All right, are we ready for page 2?
Yes, I need to do it real fast.
All right, so
Give me just a second.
we are going to pause this tape
Pause.
because we have to get the next page. So we'll have part 1, part 2.
Just a second.
Like, share, subscribe.